So our first theorem is the triangle proportionality theorem. Please write, if a line is parallel to one side of a triangle, and intersects the other two sides then it divides those two sides.
Oh my God, Nathan. Ow. What? You like ninja chopped my arm. That's not bruise.
Proportionally. All right, so how about Nate, you come sit right here.
Not this again.
You chopped my arm.
Let's go. You guys can't sit next to each other.
Yeah, we can. Clearly.
Nate, please move.
Keeps hitting me.
You want some stuff?
Thank you.
Yep.
Yep. All right, so let's look at what this is actually doing. So if a line is parallel, now you guys have seen this before. Remember, back in chapter 5, don't put this in your notes, just watch. Back in chapter 5, we had something that looked like this. Do you remember what we called that segment? The mid-segment, right? And what was true about the mid-segment?
But it's the same as the bottom.
It's not the same as the third side. If this was 8, this was 4. What else was true about the mid-segment? It was parallel to the third side, right?
I was going to use this pencil.
Come on, Nathan.
All right, so because it was the mid-segment, we knew it was parallel to the third side. Because it's the mid-segment, then I know that these are midpoints. So let's say this length was 5, this length was 5, this is 6, and this is 6. If I read this theorem, it says, if a line is parallel to one side of a triangle, well, we knew that a mid-segment is parallel to the third side of a triangle. Then it divides those sides proportionally. So notice here, let me get a different color. This green, if I set that up with a ratio to the bottom half, what would that ratio be? 5 over 5, which is 1. Do the same thing on the other side. Do you get 1? Yeah. Okay, so parallel to the third side, your sides are proportional. Now what happens if I move that line segment to no longer be in the midpoint, and we put it kind of up here? So that now this is 2 and this is 8. And this is 3 and this is 12. Are my proportions still the same? Is 2 over 8 the same as 3 over 12? So then I know that this has to be parallel to it.
Wait, what did you just say? Something about 3 over 12?
2 over 8 is the same as 3 over 12. 2 over 8 is 1/4, 3 over 12 is 1/4.
Come on.
So if we look at this first example, we want to solve for x. So I would like you to put a little star up here, because the moral of these theorems is going to be write it as you see it. So look where your x is. Your x is up here at ST. What is x physically over? 16. So I can make a ratio of x over 16 and equal it to, what would the ratio be on the other side?
5 over 10.
Good. 5 over 10, which is 1/2. You could reduce that if you wanted to make your math a little bit easier. So if I do that, x over 16 is equal to 1 over 2. So 2x equals 16. X is equal to 8. Okay? So you write it as you see it. because my line is parallel to the third side, then the two segments created by it, I'll highlight them here in two different colors, or is that yellow again? There it is. So yellow over blue should be equal to yellow over blue. Or maybe you would see it as yellow over yellow equals blue over blue. Does that still get you the same cross products if I do that? X over 5 equals 16 over 10. Do I still get the same cross products? Yeah. So if you're doing yellow over blue, then make sure the other side is yellow over blue. If you're doing yellow over yellow, then make sure the other side is blue over blue.
Or geometry.
If you do yellow over blue,
I'm trying to block the tennis ball. He's about to launch at my face.
Okay, flip it back.
What?
I moved you so that you would stop bothering
I don't
people.
have anything.
You just dropped a tennis ball.
She's not
It
dumb.
must have came off.
I had to take away a compass from you. I had to take a meter stick from you.
I was trying to use a pencil because I don't like this pen.
Then come in with a pencil. It's that simple. If you don't like writing with a pen, then come in prepared with a pencil. Okay, so make sure, do not do this over this and then this over this. Don't mix it up. All right, so now the converse of the theorem of triangle proportionality states the following. Please jot this down. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So in the next example, it's going to ask you, can we determine whether the line going through the triangle is parallel to the third side? And for that to happen, we need to check our proportions. So what would you put 90 over top of? 72. We want to see, does that equal?
Am I supposed to be ready with this box?
Nope. No. Is that equal to 50 over 40? So you could check your cross products. If I had a calculator, I could do a quick 90 times 40, which would be 3,600. Then I could do a 50 times 72, which is 3,600. So my cross products are equal, which means that my proportion must be true. So is it parallel? Yes. So yes, it's parallel. If these were not the same, then I would say no, it's not parallel because my sides are not proportional to each other. Okay, questions with that theorem and its converse? All right, so the next scenario that we are going to have, please write in the next blank box, if 3 parallel lines intersect 2 transversals then the segments intercepted on the transversals are proportional. Do you remember what a transversal looks like? Remember back in chapter 3, we had parallel lines and a transversal? You guys remember that? So now what's happening is instead of having 2 parallel lines, I'm going to add a third one to the mix. And instead of just 1 transversal, I'm going to have 2 transversals. So if three parallel lines, parallel, intersect two transversals, so here's my two transversals, then the segments intercept it. Now see if you can see these segments. Here I have a segment, and right below it I have this segment. Do you see how the same segments are over here? So I have this segment followed by, where's my yellow again? There it is, this segment. So if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So what could your proportions be? Yellow over pink is equal to yellow over pink. Or yellow over yellow is equal to pink over pink. Okay? So you write it as you see it. So if I needed to solve for, let's go with y first. What is y physically over top of? 26. So I could do y over 26 equals, then what would I do on the other side? Good. 16.5 over 15.
What's 30?
Huh?
What's C 30 and X 30?
Well, that's going to help us to get us the x. So then we get 15y equals 429 divided by 15, which gets us 28.6 for my y. Give me a ratio for x. Perfect. So we could do 15 over x is equal to 26 over 30. So 15 times 30 is 450 equals 26x divided by 26, 17.3. We'll get you your x. Okay? So write it as you see it. What is it physically over top of?
You couldn't say X over 15.
If you did x over 15, then the other side would have to be 30 over 26. So that would be totally fine. Or you could do 15 over 26 equals x over 30. That would be fine also. Okay? All right, third scenario. If a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So let's break this down. What does bisect mean again? Cut in half. So if we have a ray bisecting an angle, then what's going to happen is it's going to split that opposite side into two segments. Top segment in yellow, bottom segment in blue. Those two sides will be proportional to the other sides of the triangles. So my blue would be proportional to this blue side of the triangle, and my yellow, where's yellow? Spinning my wheel, there we go, would be proportional up there. So how could we set up a proportion? Well, we could do yellow over blue equals yellow over blue, or we could do yellow over yellow is equal to blue over blue. Okay? Yeah, so if we look at the next one, oops, come back. You're doing 5 over 6. So if we do 5 over 6 for one of my ratios, then my other one should be what? 8 over x. That would work. Would it have worked to do 6 over x equals 5 over 8? Sure. Either of those work. Cross multiplying that gets me 5x equals 48 divided by 5, 9.6.
Could you also put it down 6 over 5, x over 8?
No. So if you do 6 over 5, oh, yeah. X over 8. Yeah. Because notice you get the same cross products,
Oh,
right? Okay. All right, now this next one's a little bit more challenging, as we have to think a little bit harder about this. Remember, my sides that are split from that ray that bisects my angle are proportional to these sides. So, where's yellow? That's green, close enough. So my yellow over yellow needs to be equal to blue over blue. Or yellow over blue, bless you, is equal to yellow over blue. Give me this yellow over this blue as a fraction. 7 over 13 is equal to, I know that this blue is x, but what would be the yellow up top?
7.
We don't know what that is. So it's going to be an algebraic expression.
I have a quick question.
Yeah.
I thought you said that the yellow and yellow are the same, so why wouldn't...
They're not the same, they're proportional. So it does not mean that they are the same length. So that means I could make a ratio out of them. Okay. Well, let's just pretend for a second. If x was 10, what would be the top half?
5.
If this was, right. So if this is 7, this would be 6. No. It's going to be an expression.
What's an expression?
So it's going to have a variable in it with no equal sign.
15 minus.
15 minus x. Good. Because if the whole thing is 15 and the bottom half is x, then the top half is going to be 15 minus x. So now we got to solve that. I'll take the easy cross product. That's 7x. What's the other cross product going to be?
195. 195.
Minus, not x. Distribute the 13 to that, so minus 13x. So add your 13x over, gets you 20x equals 195. So what does that get us?
9.75.
9.75. Okay. All right. Now we're going to go through the hardest problem that you'll have on your homework, similar to this. You ready? Okay. So now we've got to solve for a whole bunch of variables. I see an A, I see a B, I see a C, and I see a D. We've got 4 different things we need to solve for, which means I'm going to do 4 different proportions. There's an E too? Oh, there is an E too. Oh my goodness. And an F. We've got a whole bunch of stuff we got to solve for. So if we first start on the sides, because all of our theorems said, if you remember from our first theorem, it says if a line is parallel to the third side of the triangle, then the segments created are proportional. So give me a ratio to solve for f. F can physically go over what? 10. So we could do f over 10 is equal to what over what, gentlemen? 12 over 15. So cross multiplying that gets us 15. F is equal to 120. Divide by 15, not 5, it's 8. So F is equal to 8. So now I'm going to put an 8 in place of F, because maybe I might want to use that 8 later on. Can you give me a ratio to solve for E? E over 5 is equal to,
12.5 over B.
well, we don't know B.
Can we do 12 over 15?
Yeah, I would like that better, because that would be actually 2 numbers. If I did know B, Taylor, then we could use that. I don't know what B is right now. So 12 over 15.
That works even though it's not directly over.
What? This 12 is over this 15.
Oh.
I'm doing E over 5, 12 over 15. 8. Is that what it is? So E is equal to 4. So I'm going to cross off E and make that a 4 because maybe I might need to use that later on down the road. Okay. Is there any other variable that is on the top or the bottom? B. Okay, so let's do a B ratio. 12.5 over B. 4 over 5 would work. So 12.5 times 5 divided by 4 is, I'm getting 15.625. Is that what you guys got?
What is? Yeah.
Okay, so now we've got all the parts that are the proportional segments from our triangle proportionality theorem. Now this is where the tricky part comes in to get these A, C, and D, because they're not on the parts that are split by segments. Okay? They're on one of the whole sides of our triangles. So, does everybody see there's 4 separate triangles going on in this diagram? There's the small one right here. And then there's the next size one, the second one, third one, right? And then the fourth one would be the whole large one.
I see it now.
You see it now? So me personally, what I like to do with these problems, I'm going to erase all this to give myself some space, is I like to actually label, actually I probably should keep those numbers there, each of the triangles separately, just so I can physically see it. So I'm going to make a little triangle. Here's my little triangle off to the side. Its dimensions are 8, D, and 10. Do you need to run to the office?
No, I just can't stop laughing.
Okay, so the next size triangle, I know that this length right here is given to me as 12.5. What's the length of this whole side? Not 12, it's going to be 12 plus 8, so that's 20.
I thought it was 12.
I'm focusing on this triangle right here. My bottom length of that triangle is 25. Good. Can you set up a proportion right now to solve for D?
Yep.
What can we do? D over 12.5 is equal to 8 over 20. So 8 times 12.5 divided by 20 gets me 5. So D is equal to 5. So now we got that. That was good. So I'm going to turn that D into a 5. Because it might be nice to use that so we can use smaller numbers. All right, so now let's get C. So that triangle I'm going to make here, we have C here. What's the whole top of that triangle? 24. The whole bottom is 30. Good. So using, ignoring this triangle, using these two triangles, can you set up a proportion to solve for C?
Yes.
What would you do?
C over 12.5.
I would use this one because it's smaller numbers.
Smaller.
Yeah.
C over
I mean, you could do that, but it would get you the same answer. So I could do C over 5 is equal to what?
8 over 24.
If I'm doing C over 5, then I should do 24 over 8, right? So 24 times 5 divided by 8 gets me C is equal to 15. Okay, so can we do the last one for A without making the triangle? What can we put A over top of? A over, what did we just say C was? 15? Okay, so if we do A over 15, then what are you going to do?
Uh, 30 over 10.
Oh, this is.
I would have went here with my 5, 8, 10, but that's okay. So 15, let's do the top half. So A's top half's whole length is what? 20 plus 4 is 24. 24 plus 12 is 36.5. What's the whole top length of the triangle that has C as its left side? 24. Good. Again, me personally, I would have went with just 8. Like I would have done A over 5 is equal to 36 over 8. But it gets to the same thing. So cross multiplying that, 36.5 times 15 divided by 24 gets me 22.8125. Okay? The one on the homework is not as many variables. That's a lot of variables. Yeah. So it's easy when your unknowns are on the broken up segments. It gets a little bit more challenging when your unknown is on the actual parallel line itself. That's when you have to think about it as those individual triangles like we did there. All right.